to the Water Safety Onboard Yachts webinar. Today we're going to be talking about water safety. We have Ashleigh West from Octo Marine, co-founder and managing director. Some of you might already know him. He's been in the industry for quite a while, sorting out our water on board, making it safe and giving us great tips of how to improve the quality of our water. So we're going to hear more from him today about that. We've also got Paul Walsh, who is from Rome Technology and a member of the UK Water Management Society. Paul's going to give us a wider scope of, in different sectors of the maritime industry, how water safety is addressed and common statistics and findings that they have found. So thank you so much for contributing towards this really important conversation.
Thank you, firstly, for taking the time out today. My name is Paul Walsh, and I'm going to share my screen now and start the presentation if that's okay with everyone. So today, I'm going to touch on a subject really that I'm sure we all have a lot of knowledge, or some knowledge, or a small amount of knowledge on. And hopefully I can create a lot more discussion in this area where we feel that it's needed. And that's the hidden threat in maritime water systems. So before we sort of get into it, I thought it'd be worth just, and I don't really like doing this bit, but give you a little bit of background on me. That's me on the left, not me on the right. And so I am currently the global business leader in industrial and medical for a company called Rome Technology. And we manufacture environmentally responsible and sustainable products mainly for water treatment. I've been involved in this industry for over 15 years now, which isn't a huge amount of time in comparison to others, but it's been a bit of an intense time, shall we say. I was very fortunate to be a contributor to the UK Legionella guidance that was written back in 2014, published actually in 2014. So I was part of a team that was really engaged to develop that guidance and how we could improve and raise standards. I've been a member of the UK Water Management Society for probably about 12 years now as well. And the UK Water Management Society is a non-for-profit in the UK, and it is literally all about advice, training, communication, and helping organisations and governments, both UK and European, to really on the management of UK water systems, and I suppose specifically there with most focus on Legionella. As I mentioned, I work for Rome Technology. We're a Belgium-based company, but we have offices in many different countries around the world, and we're present in about 72 countries at this moment in time. And finally, I love sharks. I have a bit of a passion for sharks ever since I first watched the Steven Spielberg Jaws movie, right the way through to cage diving with great whites off the coast of South Africa, and I genuinely I love them. There's no other way of describing it. So it's a little bit about me. Moving on very quickly off that bit. So, what are the threats in our water systems? Well, any water system does have potential microbial risks in the tap water, from E. coli, which could cause some severe stomach issues, abdominal cramps, nausea, vomiting, diarrhea. Legionella could be a very, very serious issue, especially if inhaled with contaminated aerosols through, say, shower systems or hot tubs or decorative water features. Sorry, someone's trying to call me. Pseudomonas, and talked about and a lot more these days than it was a few years back is biofilm. Biofilm is effectively the ecosystem that allows a full range of microorganisms to live, breed, feed, and actually be protected from certain forms of disinfection as well. A lot of these risks that we can see here, and I've identified some of the Hollywood stars of it, a lot of these risks can be increased significantly with warmer water temperatures in the water system, stagnation of water systems, so not being used all the time continuously with throughput and flow. Maybe the pipework might not be designed correctly or well. Sometimes you find it in buildings where there will be an original architectural design, and actually when it comes down to the operational installation, some of those pipework and outlets won't be needed. So they become dead ends or dead legs. Corrosion and scale can cause an issue, and inadequate methods of disinfection can also cause some problems. On board a vessel, what is the impact of a poorly managed water system? Well, the main one obviously being crew or passenger illness. Through any of the microorganisms that I've mentioned here would cause a significant issue on board either a commercial or a private vessel. Compliance, vessels being stopped at port, not being allowed to sail, not being allowed to move, fines, or even enforcement toward responsible people, which would usually be either chief engineers or captains. Onshore or shoreside delays, if your water testing fails, so you've got operational disruption, possibly missed charters, possible, no doubt, reputational impact if the water systems are not managed adequately. And then an actual commercial cost. Well, we did a bit of a study with a commercial shipping company recently that had a large fleet, and all they did was supply bottled water because the water systems on board were really challenging to manage for them. And the crew would not drink the water. It was really heavily chlorinated. They wouldn't drink it. It smelled. But there would also have some issues where on certain vessels where there was illnesses. So they ended up supplying bottled water. A little calculation there of 100 vessels, 8 crew per vessel, 2 litres a day, which is the recommendation, across the year with a few days off, it could be in excess of 400 to 450k a year just on bottled water. So not only does it have health risks, not only does it have legislative and compliance risks, but actual commercial costs just by not managing a water system correctly and adequately. Just jumping into a little bit about Legionnaire's disease, for those who don't know. Legionnaire's disease is actually a form of pneumonia, and it's contracted by breathing in contaminated, misted water that is contaminated with Legionella bacteria. It's a very, very dangerous disease, and is quite really specifically more dangerous to adults over 50, anyone with a weakened immune system, or those with any chronic lung or chest issues, and smokers. What's frightening about Legionnaire's disease is that 1 in every 10 who will get sick with it will die due to complications. And a lot of the time, it goes unreported because people don't actually understand what it is that the issues are. It's even worse in a healthcare facility where 1 in every 4 would die, mainly because of their compromised immune systems. Now, where would we find it? Well, the CDC put this kind of image together, which is the US Center for Disease and Control. To say that Legionella is ubiquitous is an understatement. So if we take this as a building, you can apply this logic to anything that has any form of piped, stored water system. So showers, hot tubs, decorative water features, the main water flow, unoccupied or unused water outlets, rooms, areas. What is also largely unknown to the kind of to people who aren't necessarily in the industry, is that there are over 60 different species of Legionella bacteria. But the one that causes the most issues is Legionella pneumophila serogroup 1, or SG1. And this is responsible for between 80 and 90% of the positive Legionnaire's disease outbreaks and cases reported in the world. What's also known is there is a direct link to biofilms in a system. So Legionella will happily base itself in a biofilm. It has food, it has protection, it can breed, it can proliferate, and it can spread. And because of the risks to human health, there is a legal requirement to not only control Legionella bacteria, but also to prevent its proliferation or its growth. That legal requirement is usually have somebody who would be known as a responsible person sign their name on a document. What's quite frightening about that is the responsible person, if this goes wrong, could be liable personally for corporate manslaughter. So it's not something to be, it's not just a box ticking exercise or we have to do this. It's about really understanding the severity and the rationale as to why we do this. Touching on biofilm briefly. So biofilm inside a pipe system, and I guarantee you pretty much everybody in this webinar will have experienced or seen biofilm at some point in the past. In fact, if you go to most taps on a water system and run your finger under the faucet, you'll get some bits coming out. If you look at a shower head, most of the time you will find deposits on the nozzles inside the shower head. That's biofilm. And it starts with the adhesion of microorganisms to the surface of the inner parts of a pipe. That adhesion starts to form small colonies. The biofilm starts to grow, develop, and becomes a lot more mature. It will then move. Once we have a production of this, what's called an extracellular matrix, which is like a sticky, glutinous kind of look and feel, it will then slough off, it will move from that part of the pipe, and it will then move away through the system and recolonize elsewhere. So you end up with pockets of biofilm throughout the pipe system. Now, forgive me, anyone who's either eating right now or has eaten recently, but I'm going to show you some pictures of biofilm, and it is not pretty. This is where we're at. This is what biofilm looks like. So we've got quite severe biofilm there inside a pipe system. You can see biofilm connecting through to scale on the shower head, and then on a filter, which is there specifically to stop contaminations. You can see biofilm clogging up the filter and aerators. So, I mean, we could have called it there the biofilm, the not so hidden threat. Biofilm is visible, very, very visible, and you can see it. And it gets a lot worse on systems that aren't as well managed. Majority of the people in this room, I'm sure, will stay in hotels at some point. Always check your shower heads in any hotel that you're staying at. What does it look like? Well, this is a little video that we use with an endoscopic camera. And this is actually in a drinking water system of a poultry farm. So this is literally a broiler farm, meat production. So chickens that we would eat, we'll buy from the supermarket, will be drinking this water that you can see in this video. Not only have you got biofilm deposits on the inside of the pipe, but this is also the proliferation of it moving around the pipe during flushing and usage. And when you actually remove the nozzles and the outlets from there, you could potentially end up with something quite as serious as this. So this is the kind of almost like wallpaper paste snot type deposits of what biofilm could be. However, if you do get your treatments right, and you get your plan and your water management correct, you would end up with a system that looks like this, practically brand new. This is actually the same system, by the way, post-treatment. So not only have you got an effective, clean system, but the flow is also efficient at this point, and you are compliant, and you will pass water testing in any port that you go through. And importantly, the people on board, whether that's crew or visitors, passengers, they're safe. Whether it's super yachts or commercial shipping, the water systems are very similar. We have a need to make sure that there is safe water for all on board the vessels. Guest and crew facilities, so showers, taps, washrooms. We have hot and cold water systems. Sometimes, majority of the time, certainly on super yachts, but we have wellness and leisure areas. We would have that potentially on cruise liners, on certain larger scale commercial vessels that would take on passengers. Storage and distribution, so we've got tanks and pumps and pipe networks, possibly freshwater tanks, freshwater hoses. Food and beverage systems, ice machines, galley operations, HVAC operation, cooling towers and condensers. So all would use similar systems to each other. So the need is shared. The requirement is shared. Some reports that have been done over the years in regards to Legionella, really, and the presence on board vessels. This particular report that I'm going to go into now was done by the Ministry of Health, the Italian Ministry of Health in Sicily, and the University of Messina. And this was about the prevalence of Legionella contamination in marine vessels and the implications of such. What was quite frightening, really, with what came out is some of the infographics that you can see on screen. On the ferries, 64% of the samples that were taken showed positive for Legionella bacteria. 4% of the water samples taken on the cruise ship were positive for Legionella bacteria. Now, bear in mind, even though it's only 4%, 6 out of 136, the amount of passengers that you are talking about on board a cruise ship raises the risk significantly. Legionella bacteria positive samples was found cruise showers, nearly half, wash basins, water tanks, less so on the drinking fountains and other areas. The crew facilities had the greatest risk, 48% positive samples versus 12% on the passenger showers. Now, that could be for many, many reasons. Could be the fact that they're not used as much. Obviously, passenger showers are going to be more, that system is going to be more prolific. There are going to be many more people using the showers more often. So the throughput will be higher. What was quite frightening was is that of the 21 samples taken, 36% were positive for the most dangerous form of Legionella bacteria, Legionella pneumophila, serogroup 1, the one that's responsible for 80 to 90% of Legionnaires' disease outbreaks around the world. This was found on board the ferries. 67% of the lower level of samples, so only 6 positive samples, but 67% of those were also serogroup 1 on the cruise ships. It's not just the presence either. The concentration was disturbing. The call to action levels on board the ferries was 10%. 10% of all of them needed immediate action. So that means the ferries needed to stop allowing visitors, passengers to come on board. 3% were of extreme critical nature. Now, yeah, there's a number of reasons why this could be the case. The ferries may less formalized maintenance, possibly intermittently used outlets, limited crew resources. There could be many, many reasons. And cruise ships, slightly differently, they would have more robust water safety plans in place, more frequent maintenance, possibly more robust disinfection and verification procedures in place. But even so, the presence of the bacterium was still there and still in a very, very dangerous level. Another report that came out, which was done only a few years ago, all about the colonization on non-passenger ships, merchant fleet really, calling at Belgian ports. Now, this particular report was presented at the Public Health Congress on Maritime Transport in 2022. It was also published in the Medical Sciences Forum. The data held within this report was of such as eye-opening nature, and still is talked about to this day, to be quite honest with you, because these things haven't gone away. This report would still be valid to this day. It's only a few years ago. Of 132 cargo or 401 vessels inspected in total, cargo, chemical, and container ships, 77% of the pervasive fleet had pervasive fleet contamination. So that means they tested positive for Legionella at least once, and 55 of the vessels were at critical outbreak risk levels, so greater than 10,000 CFUs per litre. So this is the call to action. Your ship cannot move. It will be held in port until you deal with this problem. It was shown that the temperatures on the water systems presented the ideal growth conditions for Legionella. So between 25 and 48 degrees being held at. And what the report did show, which was interesting, is that modern ships are not immune. Half of the ships in the study were between 1 and 10 years old, showing that the colonization is a risk across the entire fleet, regardless of age. Some of the issues you'll find is, even at the point of manufacture, is that the water systems will be stress tested and the water can be left in, even though potentially it could be pasteurized as a form of disinfection. You still create conditions for biofilm formation and therefore microbiological proliferation. As we mentioned, water was consistently in the ideal growth range for Legionella. There was pervasive biofilms throughout all of the systems where the positive counts were being found. And there was a bit of oversight. So who was in charge? Who was managing this, policing it almost? Was it flags of convenience? Is it the Port Health Authority? Is it the chief engineer, the captain, the owner? Who is it? Who has ultimate responsibility here? And it was found that there was gaps in this kind of responsibility. Final report that we wanted to show you was done by the UK Health Security Agency and printed in the Cambridge University Press. And it was a report based on the high prevalence of Legionella in non-passenger merchant vessels. Obviously, in this industry, it doesn't matter whether it's non-passenger or passenger, the systems are very similar. And so the data is transferable. $550 vessels were surveyed over a 3-year period on UK major ports. 803 culture samples taken and 1,027 general microbial quality samples taken. Out of those 550 vessels surveyed, 58% had at least one positive Legionella result. The contamination levels in certain aspects exceeded critical safety limits, and in some cases, 8.2% of those cases, severe contamination to the point of, again, a serious health risk. And 36% of the samples were identified as the most dangerous, Legionella pneumophilus serogroup 1. The areas where the samples showed the most problems were in hot water taps, over 50% positive, showers in the cabins, 50%, just under 50% positives, and hospital showers, which is an extremely dangerous area, as you know. And the problem was systemic. 60% of the Legionella positive show contamination at multiple water outlets. So it's not just in one area. It will move. It will say, as we said earlier on, it will respread. Biofilm can house throughout the entire system. And what was also quite alarming was that 94% of the contaminated vessels operated on international routes, which suggested that the merchant ships act as vectors contributing to the global dissemination of Legionella between ports, UK and international. So what can we do? What technologies are available for us to combat these issues? Well, there's a couple of technologies I'm going to address here. One is chlorine, one is silver stabilized hydrogen peroxide. You'll guess which one I'm a fan of. And it isn't this one. So chlorine, probably the most highly and widely used for water treatment. Historically, for as long as I've been alive, if something's dirty, we throw bleach at it. That's always been the way. But actually, chlorine or sodium hypochlorite, and it's available in the maritime industry at this moment in time for use in water treatment. But there's a number of things about chlorine that just don't. We've learned a lot more over the years, and now our knowledge about chlorine is very high. Its stability is quite poor. If you're in a hot tub or in a swimming pool and you can smell very strong levels of chlorine, that means the chlorine is out of the pool and not in the pool. You can smell it gassing off. It is highly affected by pH and temperature. So unless you get the pH absolutely right and the temperature absolutely right, chlorine will not work as effectively or at all in some cases. It has potentially harmful byproducts. There are now over 160 proven carcinogens as byproducts of chlorine disinfection. One of the most well-known of those are THMs, or trihalomethanes, which are responsible for a lot of cases of bowel and stomach cancers. Not biodegradable. Its efficacy is restricted, so chlorine is very well documented now to have little to no efficacy against biofilms, which, as we know, houses all of the dangerous microorganisms that we're talking about. And it can cause significant issues with the actual system itself. On the flip side, we have advanced stabilized hydrogen peroxide. It's a very stable product. It's not affected by pH or temperature. Doesn't have any harmful byproducts, odor or taste. Completely biodegradable. It has proven efficacy against biofilms. So we get to the root of the problem with stabilized hydrogen peroxide. You will physically destroy and remove the biofilm from the system, as we showed in the earlier slides. And it's eco-certified, which means we're not putting a harmful footprint on the world we're living in. Now, can you use it? That's the problem. You know, are you legislatively and compliance-wise, are you allowed to use it? Well, remember, I talked about me being very fortunate and being able to be a co-contributor to certain guidance. This is the guidance. This is HSG 274 Part 2. And very kindly, the Health and Safety Executive allowed us to have a paragraph. And this is our paragraph. So it shows the guidance for the control of Legionella bacteria. Silver stabilized hydrogen peroxide is approved to be used. You can use it as long as it's in line with manufacturer's instructions. This guidance is important because of this MSN guidance. The Maritime and Coast Guard agencies, we know, produce these guidance, and they reference the HSG 274 guidance specifically. And they also mention that it's good practice to add stabilized hydrogen peroxide recommended to levels recommended by the manufacturer when loading your fresh water, but also you can have an automatic dosing system to effectively look after your water treatment thereafter. What's important to recognize here is that not all stabilized hydrogen peroxide are created equal, and that some, not all, but some are not actually allowed, registered, or compliant to be used in human drinking water systems. And that's where specialists like the PYA and Octomarine can advise you and anyone in the industry how to navigate that challenging area of which products and where. And that's it. I tried to keep it to a tight half an hour to save you falling asleep and being bored by it all, but hopefully that's covered a number of the areas and the issues that you'll find within the water systems. And I think I don't know whether you want to do questions now or move straight on to Ashleigh.
Yeah, no, that was great. I think it was really important to see those statistics. Sometimes they're hard to chew through, but you explained them really well, and it gives us an overall view of actually what the situation is and what we're dealing with, not just in this industry, but the maritime industry as a whole. I had a question going along about biofilm. When you find biofilm, so whether it's the scale on the shower head or in the taps itself, where you feel that slime at the end of the taps, like you were describing,
Yeah.
Does that always mean that there is Legionella or a harmful bacteria present, or is it just cause for concern for extra investigation?
Okay, so it doesn't always mean Legionella, but actually, majority of the time it will.
Okay.
But it will mean the presence of bacteria, no question about it, because biofilm is an ecosystem full of bacteria. So yeah, it may not mean specifically Legionella, but it could mean Pseudomonas. It could mean E. coli. It could mean a variant of other harmful bacteria that would cause significant health issues to crew or passengers. The best way to find out exactly what's going on is to have some water testing done and to keep your water safety plan really robust, up to speed, and maintained. One of the key elements of a water safety plan, I'm not going to go into it because I know Ashleigh wants to have a good talk about this, but is understanding why you're doing it. It's not just to tick a box to, oh, well, we've done it, so that's okay. It's to protect you, it's to protect your teams, and it's to protect your passengers. And that's why it has to be taken so seriously. So if you have got gunk coming out of your taps, the problem is far more widespread than just that one tap. It could be very serious. It could be not quite as serious. But the fact is, it needs dealing with. And that's why you need really to get a proper water safety plan in place, but some proper water testing done to identify the issues within that system.
We can move on to yours, Ashleigh. So whenever you're ready.
So I'd just like to say thank you to the PYA for organising this, and to Paul for that very interesting presentation, and of course to everyone that's listening. And I hope this is informative to you. For people that don't know me, my name's Ashleigh West. I've been in the yachting industry since 1991. I've been in the Walsh treatment industry now, in the marine industry, for 26 years. So I have a fair amount of experience in talking about the problems associated with water systems. So that was an interesting insight into the problems in the commercial vessels and what's going on in the systems in the commercial vessels. Unfortunately, the yachting world isn't a great deal or any better. So we're here to talk about exactly what Paul was talking about: the safety of the crew, the owners, the guests, and yes, costly downtime. I mean, people listening, you've all heard of charters being cancelled or owners not getting on board because there's problems. rumours about people getting ill, which I don't really want to get into because I don't want to put a negative spin on this. My presentation is hopefully going to be positive in what we can do. So the importance of keeping the system fresh and clean and potable. Well, it starts with water analysis, as Paul said. You need to have water analysis to know what's going on. And this is something that we've seen a lot, and it's the yo-yo, the 6-month yo-yo. So yachts have water analysis done. The results are bad. They do an application to remove the biofilm and the bacteria. Then they have more analysis done, and the results are good. And then 6 months later, because they have to have the sanitation certification, they do more water analysis. The results are bad. They do remedial action. They have more analysis. The results are good. The ideal situation is we get a straight line. We don't have this cycle, this 6-month cycle of bad results, action, good results, bad results, action. So the water safety plan. Now, everyone's heard of this. The WHO Ship Guide to Sanitation strongly recommends or insists that there is a water safety plan. A water safety plan needs to be an organic document. It's not something you keep in a drawer. It comprises of 3 main areas. The system needs to be assessed completely to find out if the equipment's been installed correctly, if there is the correct equipment, works that need to be done, then operational monitoring of how this is going to be run, and then managing the system communication. This is an example of a water safety plan, the risk assessment and what it is. Now, you can buy a risk assessment off the shelf. It doesn't have to come from a company. Everyone can put a water safety plan in place themselves. If people feel they need help, then go out. There's lots of companies out there. Go and get help to have one put in place. Without a correct water safety plan being operated, there will be bacterial infections on board. So out of the risk assessment for the water safety plan, what comes out of it, it's standard operating procedures. So these are how you are going to operate it on a daily, weekly, monthly basis. The bunkering procedure, how to use all of the equipment, whether it be a softener, a point of use drinking system, having a flushing procedure in place so that every non-used outlet is flushed on a weekly basis. Sterilisation procedures and sterilisation equipment, as Paul mentioned, so that the equipment that you're using for sterilising the water is fit for purpose and working, preferably. Weekly analysis testing on board. Now, this is an obligation. This is something that every engineer should be doing on board. Okay, you should be measuring the pH, the conductivity, the temperature, and the residual sterilisation, and logging it. And the importance of logging it is then you can see the trends. You can see if the residual sterilisation is going down. Well, if it's going down, that would indicate that you have the beginning of a biological problem on board. And all the other equipment will follow with the standing operating procedures. Okay, so these are photographs of what happens when shock treatments are done when the results are bad. This is, well, one of them is a spa. That's what's in your spa. So when your guests are happily sloshing around in the spa, this is all that's in the heaters and the pipes and the filters. And on the right-hand side, that is what is in a freshwater system when the treatment's coming out. That is the biofilm being cleared out of a system. So I want to go back to bunkering because this one's the start of it. If you like, there's a whole process. There's an A to Z process of having potable water on board. And there should be an standard operating procedure for bunkering your water. The hose should be stoppered and stored in a cupboard. The outlet on the key should be sterilised. The hose should be connected. It should be flushed for 2 minutes before being connected to the boat. When the filling is finished, it should be taken off and stoppered and put back in the cupboard. Well, I know this isn't happening. I'll give you an actual example. I was in a port 3 weeks ago, and I walked down the quay, and there were about 24 yachts on that quay. Some of them working, some of them not working. Every single hose was attached to the quay outlet. Not one yacht had taken their hose off. And what happens is you get a biofilm in that hose, and then that biofilm goes back into the system on the quay. It's not a one-way, it's not a valve that's going to stop bacteria going into the system on the quay. So it's infecting the system as well as the yachts. There was one yacht that had a transparent hose where you could see the biofilm, and a developed biofilm. The chances of them having Legionella on board are massive. So putting in place standard operating procedures is really important. Okay, so what can we do? How can we do things better now? Straight away, how can we make things better to try and improve the quality of water that we've got on the yachts? Step one, put in place a correct bunkering procedure. It's relatively easily done, and it will help. Ensure that the sterilisation system is working and fit for purpose. So, okay, the machine needs to be working, and the residual sterilisation needs to be tested every week. If you're not, it's the most important action an engineer can do to ensure that the system is working, that the sterilisation system is working, and the freshwater system is of a potable quality, is to test the residual sterilisation on a weekly basis. And then a weekly flushing schedule. Used to be standard. When I first started in the industry, it was standard that one of the interior crew would go around on a weekly basis and make sure every outlet was flushed. But let me sort of throw something in there. When did you last flush windscreen wash? Top-ups to an aircon. When did those get flushed? They're not. A complete flushing schedule should be put in place for any water that is going to stand still for more than 7 days. And then, as Paul said, do regular water analysis by laboratory. So at the moment, yachts are doing analysis, every 6 months, because they need their sanitation certificates. That's a long time to wait between analysis. A lot can happen in a 6-month period. Let me try and put it into perspective. A tomato plant, a seed, will grow, flower, and bear fruit in 6 months. That's billions of cells. 6 months in a potable water system which isn't properly managed, we're talking billions of bacteria. So what action can we take? Operational water safety plans. Yeah, that's an absolute need. We need to be putting in place freshwater budgets. What yacht has got a budget? You've got budgets for crew uniform, flowers, all sorts of things. Who's got a budget for fresh water? If you have a water system which is of a potable quality and you are safe to drink it and the crew are happy to be drinking it, and you don't need bottled water, as Paul touched on, you'll be saving minimum of €1,000 per person, per crew member on board. 50 metre, 12 crew, that's 12 to 15 grand that's being spent on water every year, apart from the impact of one-time plastics. If you took that 12, 15 grand and put it into a budget, so it's not a shock. You don't have to go to the management company or the owner or the captain and say, Captain, can I spend this money, please? Because it's already budgeted for. You have your sterilisation system, you have your water maker, the repairs that are going to need to do it, and the maintenance going to need to do on it. You've got your analysis budget in there. We'd strongly recommend that water budgets would also help to improve the water quality on board. Ship guide to sanitation. Section 1, so Annex 1 is about food. So it's about the food and how to keep food and production of food and storage of food safe on board. There's a certificate for that, chef certificate. It's obligatory. Section 2, Annex 2 is about water and how to keep water safe on board and what should be doing. There's no certification in place so far. And being within the water treatment industry, we feel very strongly that it should be certified. There is no logical reason why there is not a certificate for water. So what can we do? Easy steps that we can do, the crews can do, everyone within the industry can do, is put in place the correct bunkering procedure. Ensure the sterilisation system is working and fit for purpose. Do onboard testing on a weekly basis and log it. Operate a weekly flushing schedule and do regular water analysis by laboratory. So be proactive, manage the situation, don't react. Water needs your attention. Thank you for your time.
Thank you so much, Ashleigh. That was great. Okay, so that was a more yacht-focused section of the webinar. So Ashleigh really showed us what actionable steps we can start taking on board. I think now's probably a good time for some questions. So we can go back to the first one that we received about cost. So this particular question is asking for a 500 gross ton yacht, 12 guests, 10 crew. And you touched a bit about this, Ashleigh, about the bottles of water costing about 1,000 euros per year per crew member. To create a system that would go to that level of providing drinkable water for the crew, what sort of annual costs would you be looking at for a 500 gross ton, 12 guests, 10 crew?
Yeah, I mean, it depends on what equipment they've got on board, what their schedule is, how much water they use on a weekly basis. It's like a water safety plan. You need to study case by case of what it's going to be. I mean, the age of the water makers is going to have an impact, whether they just need a little service, whether they're going to need repairing, whether or not the yacht has a softener on board is going to have an impact, whether or not they have point of use filtration. It's all going to have an impact. So just to give a global figure is impossible in reality, because it's a case by case, each individual vessel. If there's a well-run freshwater safety plan and standard operating procedures, and the system is kept without needing treatment, remedial action to prevent something, the vessel will save a huge amount of money. The most expensive part of keeping the water safe is bad results, remedial action, and having to retest. So you've got all of the cost of remedial action, and you've got water analysis, another set of water analysis, which you shouldn't have needed to do. And if you've got the 6-month cycle, that means the vessel's carrying out 2 lots of remedial action and 2 lots of water analysis, which they don't need to carry out. So if the system is run well, it's a cost-cutting, it's effective, it's a cost-cutting system.
So the cheapest approach essentially is maintenance and implementing a water safety plan management.
To manage the system, to have standard operating procedures, it's the cheapest way to go. The most expensive thing with anything, if you don't run an engine correctly and it breaks down, it's going to cost you a lot more than doing the servicing on it.
So it's preventative rather than reactive. Preventative management is absolutely the way that you should be approaching this, and therefore the importance of taking everything that we've said today very seriously is key. And therefore, you know, things that happen, it's like health insurance. You never need it till you need it. And the fact is, this is a form of insurance on the water system, and it's about that preventative approach.
And how long per week would you imagine how much time per week would you be allocating towards the weekly maintenance?
So let's go back to a 50 metre with 12 crew and typical size vessel. Well, it won't take a great deal longer to bunker correctly. You're taking the hose off as opposed to leaving it attached. It takes you 2 minutes to flush it. So it might take you an additional 10 minutes, but it's going to save you a lot of time of not having to treat bacterial infections. That it's not even a question of time from a sterilisation system on board, because it's an obligation. Ship Guide to Sanitation, MSN 1845, you have to have a sterilisation system on board. So if you run it effectively, it's going to save you a lot of time of doing applications and taking remedial action. A well-run standard operating procedure and a managed system will save you time as well as money.
So that management system, so that weekly management system, what are we including in this? Are we including adding the chemicals or adding the advanced stabilized hydrogen peroxide? Are we including the flushing of all the systems? Does every area need to be flushed? Would it just be weekly basis taps and showers, monthly basis?
So let me jump in. Yeah, you're quite right. So normally it would be one of the interior crew that would be in charge of the flushing on the inside of the vessel, and there would be one of the exterior crew which would be in charge of flushing points on the outside of the vessel. And the points that require flushing are the points that aren't getting used on a weekly basis. So in theory, the crew showers, the galley, the pantry, they're all getting used on a weekly basis, even in off season. But during the off season, the points that aren't getting flushed on the weekly basis should be flushed. What does it take? Well, you walk down into the guest accommodation where you've got 4 cabins, and you go in, you turn on every tap and every shower, and you go back to the first one, you flush the bidet, you flush the toilet, you do all that through 4 minutes, 5 minutes. I mean, we're not talking hours to go to do anything which is going to help you save time and money by not having to do preventive, to do intermediate action. And then the sterilisation system, well, yeah, sure, it needs to be run properly. Well, that depends what sort of system you've got. If you've got an electrode system, well, you just need to check every couple of months that the electrodes aren't worn out, but you'll know that because you're testing on a weekly basis what the residual sterilisation is, depending on what you've got. If you're testing for silver and copper, or if you're testing for stabilized hydrogen peroxide, they've all got a different length of time depending on the equipment you've got, but you're not talking a massive amount of time to do it. But if you want to have an effective system, it needs doing.
Okay, so for instance, to bring it into the reality of the cruise schedule, during the season, we're going to see the taps, the showers, the hot tub, the water for washing down. All of this is going to be used on a daily basis.
Correct.
So actually, when the crew have less time, potentially their list can be smaller, and they can be, and the maintenance plan can actually be quite quick per week.
It's not a particularly time consuming. It's a question of putting. Look, I don't work on the yachts, okay, but there are standard operating procedures for virtually everything on board yachts now. I'm not talking a foreign language. And it's simply a case of having some effective ones for the vessel so that they run their water system correctly. Will it add time? Well, yeah, on a daily maintenance basis, it'll add a little bit of time, but it will take away a massive amount of time for doing remedial action, which will, and if the boat gets disabled or can't move because they've got a problem, then, okay, so give you a time frame on how it happens. You do a water analysis. Legionella takes 7 days to process. Okay, after those 7 days, you've got the results. The results are bad. The vessel can't move. Okay, we have to do remedial action. That remedial action is going to take anything between 24 and 72 hours to carry out. Then you have to wait 96 hours before you can take the analysis again, so the system's stabilized and you can see if you've cleared it up. And then you take the analysis, you have to wait another 7 days. So we're talking 3 weeks. We're talking 3 weeks of a boat being immobile if they haven't prepared it properly before those analyses are taken. And so when you've got charters coming up, or the owner wants to come and use the boat, then you've suddenly got 3 weeks potentially that you can't move if you're following the rules. Not everyone follows the rules to the letter, but as regulations are getting tighter and tighter, so just touch on regulations for the maritime industry. They have just had a whole swathe of more regulations coming into the commercial sector, and it will filter down into the yachting industry. And what we're trying to do here is we're trying to put our house in order. I'm trying to say to people, put our house in order, get things right before the new regulations come in.
Yeah, absolutely. We also have a question from a captain here. What's the correct dose for 2,000-litre tank with hydrosil?
I'd rather not answer any non-safety issues. That's a commercial question.
Okay.
I'd rather not answer that. I'm sure the person can write to us if they want that information.
Okay. Okay, great. And then there is a question about desalinated water for drinking water. I'm not sure if this is a question that could be answered by either of you.
Yeah, I'll take that one.
Yep.
So I'll take that one. A massive part of the world's population drink desalinated water. It's a fallacy that it will dissolve the calcium in your bones. It tastes bland. Okay. It's mineral free, but we don't absorb. You absorb potentially 2% of minerals from the water you drink. You absorb minerals from the food you eat. So when, especially in France, they call it mineral water, it's just advertising. It's a load of rubbish. You can drink desal water. There's not a problem with it. It's ideally you'll try and balance the pH, which is just using calcium carbonate, because by balancing the pH, you make the water more stable. When it hasn't, if it's got nothing in it, it's very unstable water. So what happens is it can potentially it will pick up any calcium that's available. It will pick up metal ions. So yeah, it's best to put it through a pH balancer after. And if you want to improve the flavor, the taste and flavor, you put it through a carbon filter. But it's perfectly safe to drink.
Okay, thank you. And going back to the regulations, when are these regulations coming in? I think this is for the commercial sector.
That's for the commercial sector.
Yeah.
But because now the commercial sector, they're trying to insist that the water is of quality where the crew can drink it. Because unlike the yachting industry, which has been very, very good at going away from bottled water, there's a massive amount of yachts that have good systems. They have point of use filtration. They're drinking the water on board, because it's not all doom and gloom. There's a lot of yachts doing a very good job out there of running their water systems as they should. You know, if Paul's figures that he were using there, I can't give you the figures of the whole industry because I don't have access to all of the yachting industry's figures. I know from personal experience that the figures aren't a great deal different to what Paul just said. So if 1 in 4 yachts has got Legionella on board and 8% have got critical situations, that'd probably be about right. But that means that 75% of the industry are doing a good job. So all we're trying to do is just help the people, the systems to get better, that they should. Safety plan, if I just go back to water safety plans for a second, the ideal situation of a water safety plan is that it's installed when the vessel is built. So when a vessel's built, at a certain point, they will pressurize the water system, put water in it, make sure there's no leaks. That is when the water safety plan should come in. It should be operated by the yard so that their bunkering procedures are correct, that they're doing water analysis, that they make sure there's residual sterilization. And then when the crew join the vessel, they take over the water safety plan. That would be the ideal scenario. And we're talking to a number of yards about this, and they can see the sense in it. So, but that doesn't exist at the moment, but it will come in. That will come in where shipyards. So if you're going to be on a new build, in theory, in a short period of time, we hope, When you join the vessel, there will be a water safety plan, an operational water safety plan in place.
Okay, and that goes back to Paul. You were saying half of the ships are that are affected by Legionella are between 1 and 10 years old. So this
Correct,
isn't
yeah.
something that we're looking at just because it's an old system.
It's not based on age systems. It can be any system that has any form of piped water distribution on there for potable or non-potable. But touching on the regulations again there, as I showed within the land-based HSE regulations in the UK, that regulation there is actually quoted pan-European. I work across Legionella in France, Germany, Belgium, Spain, Netherlands at this moment in time, UK, Ireland. And they will quote regulations from across Europe. Port health authorities will then look at government regulations to see where it might apply to their particular part of the world. That MSN guidances come because they reference other guidance where Legionella is really focused and microscopically looked at. So when we talk about regulations in whether that's for a private yacht, a ferry, a non-passenger merchant vessel, if no one is knocking on the door now to come on board, that doesn't mean they're not going to. It's not a case of if, it's when. And as Ashleigh quite rightly stated, let's get our house in order correctly, compliantly, and also really in a safe manner. And if we do it now, then there's no surprises coming down the line. You know what I mean? We're not doing it when we've got people on board, and then all of a sudden we've got a major issue.
Okay, so I'm going to read us one last question from the chat. What's your opinion on using silver sterilizers and UV lights? Is one more effective than the other?
So UV is not a standalone source of sterilization. It is a backup point of use. They're very good on the distribution side of a water tank. Okay, but they have no residual. So they won't keep your water safe. They basically knock out the bacteria. They don't kill them, they knock them out. It's very good on HPC, so general bacterial count. It's very good on. It's less good on other things. It's a secondary form of sterilization. It's the multi-barrier form of sterilization is the optimal system. So you'd have some form of sterilization prior to the tank, and then a UV after is optimal. For silver and copper, they work very well on water which is not RO water. Reverse osmosis water, the pH is wrong for the copper. It's too high. pH, RO water has elevated pH, and so the copper is made fairly ineffective. And the silver combines with the chlorides. So when you make water from seawater, it's very high in chlorides. And the silver and the chlorides combine, and they make silver chloride. And what happens is the tanks and the pipework go black. If you open up your tank and it's black inside, that's silver chloride. So it's great on dock water, but it's less effective on RO water.
Okay, thank you. And would that be, would you be able to drink this water?
Oh yeah, 100%. I mean, you can drink water with silver in, because the levels that you're putting into it aren't going to turn you blue. You're not going to, because if there's too much silver in the water, you can actually turn blue. But that's not the case. There's nothing near that level of silver in it. But once again, if you're using silver or silver and copper, you should be measuring the levels on a weekly basis to see if you've got silver in the system.
Yeah. Okay, and Mike has stated that correctly, water distribution system design needs to be improved on builds. This is something that I have heard for over the last year talked about even by shipyards. In the new regulations, is there anything about design requirements to ensure a safer, easier to maintain system?
I haven't read all of the requirements because it's getting tougher and tougher for the requirements because they want sustainable products and all sorts of things. So it's a massive document. I haven't read it all because that's not what. If someone asked me to design the freshwater system, I'd happily do it for them. And Mike's quite right. They're not ideal. I mean, in a perfect world, you'd have a chilled water tank. Your cold water system would be chilled, and it'd have a circulation on it. So it'd be constantly, you'd have circulated chilled water going around the system and under 20 degrees. And then your problem with biological growth would be much, much less. It's because the vessel's water systems, even the cold one, aren't ever under 20 degrees because it's either heated inside because it's winter, or they're sitting in the sea, which is above 20 degrees. And so it's not a cold water system. It's a water system which is perfect breeding ground for bacteria normally.
Yeah. Okay, let's have a quick look at the Q&A area. When we are operating in areas with sea temperatures over 30 to 32 degrees, tank water is stored at 32 degrees, and RO water is pulled from these high sea temperatures. Can a vessel operating under these conditions maintain a safe drinking water system? Is it possible?
If you have a sterilization system which is operating correctly and has the correct level of residual sterilization in it, yes.
And can it operate at those temperatures in a stable manner?
Yes.
And that's the point. So temperature affects a lot of disinfectants that are there, and you need them to be stable, whether that's on a cold system, warm system, whatever that is. You need the stability, because once you're out and about, you can't just pull over and try and put something in place. So yeah, some knowledge and gaining some knowledge from the people within this webinar and the industry itself on the type of technology that you're using for your water system is important.
Okay, well, thank you so much. We're going to wrap it up there. But if anybody has any further questions for Ashleigh or Paul, if you'd like to email us at info@pya.org, then we can pass the questions on, and get back to you with some answers. But for now, I'm just going to thank you, Ashleigh and Paul, for all of the fantastic information. Paul for helping us digest all the statistics, and Ashleigh for really giving us a yacht-focused perspective of water safety on board. So thank you very much, and thank you for everyone who joined today. I know you're probably all busy on your seasons, and I really wish that you have a fantastic season, a safe season. And the PYA is always here for you if there's anything that you need to ask, or if you have any concerns about this subject or any other subject, that we might be able to signpost you onto some help. So thank you, everybody.
Thank you. Thank you very much for giving us the opportunity. Thanks.